Section 4.5 is about solving exponential and log equations. We have talked about this in some of our previous sections, but these ones are going to be not quite as pretty answers. So, for example, we've got 2 to the power of x equals 40, and we know that 2 to the power of 5 equals 32, and we know that 2 to the power of 6 equals 64. So we know that our answer is a number that's somewhere between 5 and 6, but we also know it's not going to be a nice, pretty whole number. So one way we can look at this is to apply what we learned from section 4.3, I believe it was, here where we switch the form between exponential and log form. Okay, so we can use that, or we can just think of it as taking the log based sum log of both sides, and that'll get the x out of the exponent. Okay, so if we take the log, so it could be a log with any base. A lot of times on the homework, I noticed that they will ask you to put it in terms of like natural logs, in which case you could use the change of base formula to accomplish that. So there's just a lot of different ways that you could go about this. So I like to think of it as like taking a log of both sides. So you could take the natural log of both sides, and I like to use the natural log a lot if for no other reason than it has one less letter than log, you know. So that's one way to go with it. So if we did that, we took the natural log of both sides. So like ln of 2 to the x equals ln of 40. So then you could take the x and you could put it in front there. So then it would be x times the natural log of 2 equals the natural log of 40. And then to get x by itself, you would just divide both sides by ln of 2. All right, so that would give you x equals ln of 40 over ln of 2. All right. So, you know, if they asked you to put your answer in terms of natural logs, there you have it. And you can't do anything else to simplify this. You can't like reduce the 40 and the 2, make it a 20 or anything like that, because they're both inside the log separately. So, all right. So there you go. So number 2, 1/3 to the power of x equals -9. So you could take a log of both sides. So let's say you took the natural log of both sides. Well, the argument always has to be positive, so that's going to be undefined. Okay, so that means that there's going to be no solution. All right, so if you think about it, if you have a positive number and you raise it to an exponent, it can never equal a negative answer, okay? All right, number 3. So we have seen some problems kind of like this before, back in like when we talked about quadratic equations. Basically, the way we're going to solve this is similar to how we would solve a quadratic equation. So I think that was section 1.4, I believe. Or it might have been like 1.5, 1.6 by the time we got to this. Yeah, I can't remember. It's somewhere back in chapter 1. Anyway, so basically we can solve this kind of using like a substitution. So instead of e to the x, let's substitute that with a different variable. It can be whatever variable you like y or u or n or something. Let's say u. Let's use u. Okay, so u is equal to e to the x. All right, so if you square both sides of that, u squared, so multiply the exponents, x times 2, that's 2x. So we're going to replace e to the x with u, and we're going to replace e to the 2x with u squared. All right, and then it's just going to pretty much look like a quadratic. So we have u squared minus 8u plus 7 equals 0. All right, and I think we should be able to just factor that. All right, so two numbers that multiply to a positive 7 and add up to a negative 8. They have to be both negative, and it would have to be 1 and 7. All right, and that still equals to 0. All right, so that means that u equals 1 and u equals 7. All right, but we still want to solve for x. So we know that u equals e to the x. So that would be then 1 equals e to the x, and 7 equals e to the x. So if I take the natural log of both sides, ln cancels out with e, so ln of 1 equals x. Well, we also know that any log of 1 is always equal to 0. So 0 is equal to x. And then here, take the natural log of both sides. So ln of 7 equals x. So those are my two solutions right there. Okay. All right, number 4 is going to be similar to that. So it's going to be like a quadratic. Let's move the 6 over first of all. So subtract 6 from both sides. So that would make it 2e to the 2x plus e to the x minus 6 equals 0. All right, we can use the same substitution that we did on the last problem. All right, so if we say u equals e to the x, and then that means that u squared equals e to the 2x, so we'll sub it in. So that would make it 2u squared plus u minus 6 equals 0. All right, so then we can solve that for u. So we can probably factor it. Yeah, we could factor it. Or so we could use the AC method, we could guess and check, or you could also use the quadratic formula, or you could have even done like, I was going to say complete the square. You probably wouldn't want to do that in this case. Let's see. All right, so I'm just going to try guess and check, I believe. So I've got to have a 2, u, and a u. All right, so I'm gonna have I think that's gonna be it right there. So that's going to give me plus 4 minus 3. That would give me just that positive 1u in the middle there. All right. So if I say 2u minus 3 equals 0, and then solve for u, so 2u equals 3 divided by 2. So that gives me u is equal to 3/2. Okay, and I know that u equals e to the x. So I'll say basically e to the x is equal to 3/2. And then I'll just take the natural log of both sides. So I can cancel that out. So that gives me x is equal to ln of 3/2. All right. And then my other one, that would tell me that u equals -2. Oops, I went off the page, just off the screen just a little bit, didn't I? Sorry about that. All right, so if u is -2, then that means that -2 equals e to the x, where e to the x equals -2. Okay, and then I would take the natural log of both sides, except for I can't have a log of a negative. So there's no solution from that. So my only solution then is that x equals ln of 3/2. All right. Number 5. So number 5 is going to be kind of similar. Instead of e to the x, we've got 4 to the x. Okay. So let's see. So we will say that u equals 4 to the x, which means that u squared equals 4 to the 2x. So that gives me u squared plus 35 equals 12u. So let's get everything over to the left side. Subtract 12u from both sides to move it over. So I have u squared minus 12u plus 35 equals 0. All right, see, that doesn't seem so bad. It looked really freaky at first, but not too bad now. So I think we can just factor that. So that's going to be -5 and -7. So u equals 5. So that means that 4 to the x equals 5. And if you take the natural log of both sides, then that allows you to move that x there. So it's x times the natural log of 4 equals the natural log of 5. And then to solve for x, we're just going to divide both sides by ln of 4. So x equals ln of 5 over ln of 4. All right. And then basically the same thing here. We have u would equal 7, which means 4 to the x equals 7. And then you take the natural log of both sides. Which allows you to move the x here. So x times ln of 4 equals ln of 7. Divide both sides by ln of 4. So you get x equals ln of 7 over ln of 4. All right, so now we're going to switch over to some equations that are starting off with log. All right, so number 6 says ln of x equals -2. So in this case, so this is kind of similar to, we did this in section 4.3 when we did log equations. So basically what I would do is, since I know the base of the natural log is e, I put like a big E here and here. So in other words, I'm saying e to the power of ln of x equals e to the power of -2. And so then that allows me to cancel out this and this, and it gives me x equals e to the power of -2. All right, and a lot of times we don't like to leave our answer with a negative exponent, so let's change that to 1 over e squared. Okie dokie. All right, number 7 says 2 times the natural log of x is equal to 3. So the first thing I want to do for that is divide both sides by 2. So ln of x equals 3/2. Then I'll take my big E here and here. So I'm saying e to the power of ln of x equals e to the power of 3 over 2. And so then I can cancel the e with the ln like this. So I get x is equal to e to the power of 3 over 2. All right, and that might be a perfectly acceptable way of writing the answer, but we also might want to change it into radical form, in which case that would be the square root of e cubed. So either way. All right, and number 8, we have ln of 2x is equal to 5. So I'll take my e here and here, and then cancel out this and that. So that gives me 2x equals e to the 5th power. And then in order to solve for x, I need to divide both sides by 2. So x equals e to the 5th power over 2. Alrighty. And number 9, log of x plus 5 equals 6. All right, so there's not parentheses around the x plus 5, so we would know that the plus 5 is separate from the log expression. It's not part of the argument. So I would go ahead and start by subtracting 5 from both sides. So that would make it log of x equals 1. And then I know that the base of that log is understood to be 10. So I'd put a big 10 here and here. And then that would allow me to cancel out this and that. So x equals 10 to the power of 1, or in other words, x equals 10. Alrighty. Number 10, I have log base 2 of 1 minus x equals 0.5. All right, so I'm going to take a big 2 here and there. So that lets me cancel out that and that. So that leaves me with 1 minus x equals 2 to the power of 0.5. So 0.5 is the same thing as a half. All right, so that's the same thing as saying 2 to the power of 1/2, which I know is the same thing as saying the square root of 2. So I have 1 minus x equals the square root of 2. So then I could subtract 1 from both sides. So that would make it negative x equals the square root of 2 minus 1. So that's the same thing as having like negative 1x. So basically divide both sides by negative 1. So that would give me x equals negative square root of 2 plus 1. Okie doke. And that's it. All righty. Number 11, we have log base 2 of x cubed plus 3 equals 2. All right, so because the log has a base of 2, I'll have a 2 here and a 2 there, and that'll let me cancel out the 2 with the log. So that would give me x cubed plus 3 equals 2 squared. And I know that 2 squared equals 4. So that's 4. So I have x cubed plus 3 equals 4. Then I'm going to subtract 3 from both sides. So I'm going to have x cubed equals 1. Then I need to do the cubed root of both sides. And the cubed root of 1 is 1, so that gives me x equals 1. All right, number 12, I have ln of x plus ln of x squared equals 5. So the first thing I have to do is combine my logs. All right, so using our properties of logs that we learned in section 4.3, so we have to combine those and multiply the x times the x squared. So that would make it ln of x cubed. And I don't need the parentheses, but I just like them. Then I can do, since I know that the base is e, now I can do this and that. So that gives me x cubed equals e to the 5th power. So to get x by itself, I can take the cubed root of both sides. Okay. So x equals the cubed root of e to the 5th power, which is also the same thing as e to the power of 5/3. So whichever way is preferred, either way is fine to me. Okay. Number 13. All right, so let's see, we want to get rid of the log, so we'll use 2. All right, so that would give me 2x plus 4 times x plus 4 equals 2 to the 4th power. So I'll go ahead and FOIL. So when I FOIL, I'm going to have 2x squared plus 8x plus 4x plus 16 equals, and 2 to the 4th power is 16. So I can combine like terms. 8x plus 4x equals 12x. So I've got 2x squared plus 12x plus 16 equals 16. And then I can subtract 16 from both sides. So that would give me 2x squared plus 12x equals 0. All right. Okay, now what I can do is just factor out a common factor, which would be 2x. And that would leave, so that would make it 2x times x plus 6. Okay, equals 0. So that would mean that I can have 2x equals 0 and also x plus 6 equals 0. So if 2x equals 0 and I divide both sides by 2, that would give me x equals 0. And then over here, that would give me x equals negative 6. Okay. And, you know, because of the fact that these are already combined in one log, that makes both of these answers acceptable, because if I plug that in, that would be, you know, that would be a negative times a negative, so it would be a positive. Now, if I had started this problem out just slightly differently with, you know, having log base 2 of this plus log base 2 of that, if I had that situation, that would make this answer unacceptable. But because we started the problem like this, that means this answer is fine. Okie dokie. All right, let's try to squeeze in one more problem before we have to break up the video. I think I can do it. All right, number 14. So the first thing I'm going to do is take the logs that are on the left side, and I'm going to combine those by multiplying the arguments. So that's going to make it log of 5x plus 3 times 4, okay, and that still equals log of 19x plus 20, okay. Then I can basically cancel out those logs, okay. In other words, I know that it's a log base 10, so if I put a 10 here and a 10 there, that'll allow me to cancel like this and cancel like that. So now all the logs are gone. It's basically just like a normal linear equation. All right, so then I'll go ahead and distribute the 4. So that would make it 20x plus 12, and that equals 19x plus 20. So I want to get all the x's on one side, so I would subtract 19x from both sides. So that would make it 1x plus 12 equals 20. And then just subtract 12 from both sides. So that would make it x equals 8. All right. And that'll be a good stopping point. So that'll conclude part A of 4.5. And then there would be a part B.